Hi, I'm Mike Gorman. I've been working in the field of acoustic emission for about 35 years. As a non-destructive evaluation technique, AE has been around since the 1950s. The idea of listening to materials when they are under stress seems very natural. We have all heard a piece of wood breaking, and we recognize the sound of breaking glass. In AE, we think that by listening to microfractures in a material, we might be able to tell when it is time to take a part out of service. The sounds that we listen to are above normal human hearing. They are ultrasonic. Success in using acoustic emission as a non-destructive testing technique has been limited. I hope to show you that part of the problem is that we haven't been listening to the materials in the right way. In the late 1980s, I realized that most AE waves are plate wave modes and that there is a direct link between waves and sources. I call this modal acoustic emission. People have asked me what's the difference between conventional acoustic emission and modal acoustic emission. Well, there are several, okay, but I can't cover the whole subject in just a short video, so I'm going to just point out one of the big differences between modal AE and conventional AE. And in listening to those sounds of breaking glass or wood or metal crunching, what are you listening with? You're listening with your ears. Your ears are actually very wideband transducers, and your brain is a database of all those sounds. Okay, the resonant transducer you've been using just doesn't cut it. And I'm going to use sound to show you why. Okay, what I have here is a graphic equalizer, and I have a function generator. I can set this up so that you're listening like you're listening with your resonant transducer to a very, very narrow band. Usually you listen about 100 to 300 kilohertz, something like that, with a 150 kilohertz resonant transducer. So I have this synthesizer set up for 100 hertz so that we can hear it, but you can imagine that's your 100 kilohertz. We can do whatever frequencies you want, but the point is that you will hear the frequency if your transducer is sensitive to it. If it's not sensitive to it, which I'm going to show you in just a moment, you won't hear it. So here we have a low frequency tone burst. And if that's the frequencies that your source is making, you'll hear it. But what if your source is making frequencies out of the range of your resonant transducer? You don't hear it. Now, it's there, okay? Let me show you that it's actually there, but you just weren't listening to it. You weren't able to pick, your transducer wasn't able to pick that up. Nothing, now you pick it up. If you have a transducer that's set to listen to the high frequencies and the source is a low frequency, sorry, you can't pick it up. So, since sources are actually very wide band and fracture produces a whole range of frequency, and different fractures produce different ranges of frequencies, what you want to do is listen with a wideband transducer. This is just one of the differences between conventional AE and modal AE. Modal AE is now accepted by code bodies and regulatory authorities. With Modal AE, you'll find that everything makes sense. It takes out the need for tests on identical specimens in order to develop statistics. You know how you test specimen after specimen, doing different things to it so that you can develop some sort of pattern in the acoustic emission, conventional acoustic emission plots that you're looking at. Well, once you know what type of wave is produced by a fracture mechanism in a given material, that wave is going to look the same every time you test that material. You don't need to do a baseline test anymore on a structure so you can compare, you know, what it looked like then with what it looks like now. You're actually measuring directly the fracture source, and you can use theory to predict what type of wave you'll get from different fracture sources in different materials. Okay, with Modal AE, you get definite results about the type of fracture that has occurred. So that's just one of the differences. I hope to make a series of videos illustrating what modal acoustic emission is all about. See you next time.